All right, welcome. Today's lesson is 6.3, which is trigonometric functions of angles. A little vague, but you'll be essentially evaluating different trig functions in both degrees and radians. Again, good news is a lot of this stuff is already familiar to you from chapter 5, so it won't feel so new. So I'm going to start out by just evaluating a couple angles in degrees first. Okay, so notice the directions says to find the reference number, which is the t bar, and then find the exact value of the trig function. So we did reference numbers, 5.1 maybe. So it's been a few days, several days. But please remind yourself that a reference angle, reference number, same thing, is the angle that connects, the acute angle that connects from the terminal side to the x-axis. Okay, so it's always positive. So for example, when you do sine of negative 60 degrees, first and foremost, you got to think about where that angle is. So negative, you know you're going clockwise. So if I visualize on a circle, this is approximately negative 60 degrees, right? Starting from the x-axis, going clockwise 60 degrees. Okay, reference angle then is terminal side, that's my red side, connected to the x-axis, but it's the acute. So it's either going to be this or it's going to be this. Well, that's not acute. So I know that 60 degrees is my terminal number. Okay, now what's nice about terminal numbers is it's going to give you an angle in the first quadrant. So if you just know your first quadrant angles and the sine and cosine values respectively, and tangent I should say, you'll be good to go. So for example, if I go to 60 degrees, which is the same as pi over 3, I know the cosine and the sine value right here, and it's asking me for the sine of negative 60. Well, if the sine of 60 is the square root of 3 over 2, the sine of negative 60 down in the fourth quadrant, because sine is negative down there, is just going to be the negative square root of 3 over 2. Okay, same thing if I go down to cosine of 210 degrees. Well, where is 210? If you visualize that first. So this is 180 plus another 30. Okay, now think about what I just said. Plus another 30, that's my reference number, right? Because that's the acute angle that connects from the x-axis to my terminal side. So my reference number on this one is 30 degrees. So again, if I know at 30 degrees, which is pi over 6, my cosine and sine values are square root of 3 over 2 and 1/2. So the cosine is square root of 3 over 2, but in the third quadrant, the cosine is negative. So I know that's going to be negative square root of 3 over 2. Okay, going on to tangent of negative 495. That angle you have to think about a bit more. So it's negative, going to go clockwise, and it's clearly beyond 360. So starting at the x-axis, if you go all the way around once, that's negative 360, plus another 135 would bring me to negative 435. So I kind of showed that coterminal idea that you learned in 6.1. And so the angle is down in the third quadrant, and I know in the third quadrant the tangent is positive because y divided by x, negative is positive. So if I found the reference number from my terminal side to the x-axis is another 45 degrees. You can see that there. So knowing at 45 degrees, if I found the tangent there, tangent is y over x, and square root of 2 over 2 divided by square root of 2 over 2 is 1. Well, down in the third quadrant over here, it's going to be the same thing, right? So I know that that is tangent of negative 495 degrees is equivalent to 1. Okay, last one, cotangent of 750. Got a lot of stuff to think about here. So 750 is more than twice around, right? So if you go once, that's 360. Another time is 720. And then another 30 degrees would bring me to 750. Okay, so again, another 30 degrees. There's my reference angle. So at 30 degrees, I know that the tangent is y divided by x, which would be square root of 3 over 3. Well, if I do cotangent, remember cotangent is the reciprocal. So the reciprocal of tangent would now be x divided by y. So if you take the square root of 3 over 2 divided by a half, which means you're really going to multiply by 2, you will get just square root of 3. So that answer is a square root of 3. Also note, if you know the tangent values at 30 and 60 degrees, their cotangent values are flip-flopped, right? Just like the cosine and sine values. So anyway, hopefully you're getting a little more comfortable with evaluating things on angles on a unit circle. So just want to do a few in radians as well. Same directions, find the reference number and then find the exact value. So cosecant of negative pi over 3. Well, first of all, if you visualize negative pi over 3, sorry. So we're going clockwise. Negative pi over 3 would be where 5 pi over 3 is. So right there. And cosecant, you know, is the reciprocal of sine. So the sine value here is negative square root of 3 over 2. So if I take, and its reference angle, which I totally skipped over, but the reference angle here from my red terminal side to the x-axis is pi over 3, right? So if I take the sine coordinate and reciprocal it, since I'm doing cosecant, that's going to be 2 over the square root of 3, right? Just reciprocal it, and then rationalize that denominator. So I multiply by root 3 over root 3, and you get negative 2 root 3 over 3. Okay, secant of 11 pi over 2. So I'm going to bring my angle back to the x-axis here, my terminal side, and 11 halves. Well, you could count it out if you really wanted, like 1 halves, 2 halves, 3 halves, 4 halves. Keep going. Well, that's 1 time around is 4 or 8. 1 time around in halves would be 4 halves. 2 times around would be 8 halves. Then this would be 9 halves, 10 halves, and 11 halves. So I end up down at 3 pi over 2. Its reference number, since it's right on an axis, on the y-axis, is pi over 2. And I'm doing the secant. Well, the secant is a reciprocal of the cosine. The cosine here is 0. If you reciprocal 0, you're dividing by 0, and you can't divide by 0. So that would be undefined. All right, last one is cotangent. I'm going to bring my terminal side back to the x-axis. So cotangent of negative 17.6 pi. So negative, I'm going to go clockwise. So if I go all the way around in 6, that would be 12.6 because 12.6 is 2 pi. And I have to go another 7.6, right? Because I went 12.6. So 12.6, this would be 13.6, 14.6, 15.6, 16.6, and 17.6 would bring me right here, which is coterminal to 7 pi over 6. You can probably see the reference angle. This little angle right here is 1 more 6, so its reference angle is pi over 6. Okay, cotangent now is the reciprocal of tangent. So if I know the tangent of negative 17 pi over 6 is going to be the same as the tangent of pi over 6, right, since they're coterminal, but that's tangent. So now I have to reciprocal this to get the cotangent, since tangent and cotangent are reciprocals. Woo! So if I take, I could do the math. I can take negative square root of 3 over 2 divided by negative 1/2, which would be the same as multiplying by negative 2 over 1, and I get a positive square root of 3. Or I could just reciprocal this and simplify. You will also get square root of 3. All right, so moving on, you will also be asked to write, now we did a little bit of this in chapter 5, so write a trig expression in terms of another trig expression. So we're going to write cotangent of theta times cosecant of theta in terms of cosine of theta, and theta can be in any quadrant, which is nice. Okay, so starting out with cotangent times cosecant, I want all of this to be in terms of cosine. I'm going to highlight this in blue. That's my goal, right? I want to get everything in terms of cosines. So by the reciprocal identities, I know cotangent is reciprocal of tangent, and I know tangent is sine over cosine. So cotangent is cosine over sine. I also know the reciprocal identity cosecant is 1 over sine. Okay, keeping in mind I want everything in cosines, so I'm good here. If I multiply these together, just to simplify it a bit, I get cosine over sine squared. So I want sine squared now to be in terms of cosines. So now I have to reference my Pythagorean identity, right? Sine squared plus cosine squared equals 1. And if I solve that, I can just subtract the cosine over, and I can substitute this. So again, the sine squared is really 1 minus cosine squared, and now everything, this original expression right here, is in terms of all cosines. So we did one similar to that in chapter 5. Now I'm going to just amp it up a little bit. We're going to write tangent in terms of sine. Okay, but this is usually where people get a little bit hung up. The angle has to be in quadrant 3. So I just visualize, I know you know what quadrant 3 is, okay, but keep that in the back of your mind as we do this work. So I'm going to write tangent in terms of sine. Well, tangent is sine over cosine. I can start there. So sine, good. And now I got to get this cosine in terms of sine. So I'm going to go back to my Pythagorean identity, right? Sine squared plus cosine squared equals 1. And I got to replace this cosine. So I'm going to solve this for cosine. So I'm going to subtract sine squared over. And then I'm going to square root both sides. Okay, when I square root, obviously I have a plus or minus. Now here's the catch. My angle, theta, has to be in quadrant 3. In quadrant 3, both cosine and sine are negative. So I'm solving for cosine here. That's where I have to stop and think about which of these is correct. Well, in the third quadrant, cosine is negative. So it's not plus or minus, it's just the minus. Okay, this, again, when you square root something, that is the only time you have to think about this quadrant restriction. Okay, now I'm going to go back up here. This cosine, I'm going to replace with this square root expression so that it's in terms of sines. And then you will have your answer. So tangent in terms of all sines right here. Sine over, and then I replaced my cosine with this expression. All right. Another, I guess another example of rearranging trig expressions. So if you know the cosecant of theta is 6 and the secant of theta is less than 0, find the other 5 trig functions. So I listed the 5 trig functions here, right? We got to figure those out. I know cosecant is 6. That one's a freebie. In fact, if you know cosecant, you should be able then to find its reciprocal. Easy peasy. So cosecant is reciprocal of sine. So if cosecant is 6, sine is 1 over 6. That's an easy one. Okay, this, you know that the secant is negative. I'm going to come back to this. That all that is saying is if the cosecant is less than 0, negative, then you know because secant and cosine are reciprocals, the cosine's also going to be negative. Likewise here, if the cosecant is positive, you know the sine is going to be positive, right? So I'm just kind of thinking about, you really have to pay attention to positives and negatives. I'm going to go over and use this Pythagorean identity that says 1 plus cotangent equals cosecant. And I'm doing that because I know a cosecant value is 6. So I can just replace this cosecant squared with 6 squared, which is obviously 36. Now I can solve for cotangent. So I can subtract the 1 over, which would be 35, and I can square root both sides, and I get a plus or minus. And here is where I got to stop and think, it's not plus or minus, it's got to be one or the other. So if my cosine is negative and my sine is positive, that's going to put me in the third quadrant, right? In the third quadrant, my tangent and cotangent are both negative. So I know that this is the negative square root of 35. So that gives me my cotangent. Now I can figure out tangent because these are reciprocals, right? So if I just reciprocal the square root of 35, 1 over this, rationalize my denominator, I'll get negative 35 over 35. Okay, last but not least, I could do more algebra like I did over here using a Pythagorean identity to figure out like sine squared plus cosine squared equals 1. And you could do that as if you appreciate this algebra, go for it. Otherwise, I'm going to visualize my work geometrically speaking. So again, because I knew my sine was positive and my cosine was negative, I know my triangle is going to be in the second quadrant. And I know cosecant's the reciprocal of sine. So if cosecant is 6 over 1, then I know cosecant, instead of being opposite over hypotenuse, it's going to be hypotenuse over opposite. So hypotenuse is 6, opposite is 1. I can use Pythagorean theorem to figure out my adjacent side is negative root 35, which, no coincidence, I got that algebraically as well. Okay, then I could just use my triangle to figure out the cosine. Well, cosine is adjacent over hypotenuse, so that's negative square root of 35 over 6. And then secant is a reciprocal of that. So if I reciprocal and rationalize my denominator, I get negative 6 root 35 over 35. Okay, so a lot of little details in this question. Watch your positives and negatives. Think about the quadrant you're in. Visualize a triangle if you want. Do the algebra, whatever you prefer. All right, one last thing, and actually this is probably the easiest part of the lesson. You're going to be introduced to another triangle area formula. So you know area of a right triangle is 1/2, or area of any triangle, sorry, is 1/2 base times height. Okay, so if I take what you know, 1/2 base times height, area of a triangle, okay, and I'm just going to put in symbols, 1/2 b times h, and I'm going to say, what if we don't know the height? Okay, so this is assuming we just know the base and the height, like piece of cake, like if I visualize this triangle over here. So let's pretend we don't know the height. So if I just put theta down here, you could put theta wherever you want. But if I said, well, I know that the sine of theta is opposite h over hypotenuse a, right? Like you know that, SOHCAHTOA, nothing unfamiliar. And then if I multiply the a over here, so a times sine of h, sine of theta, excuse me, equals h. Now, if I go back up to my area formula, 1/2 base times height, but if I didn't actually know height, I could rewrite my height as this expression. And my new area of a triangle formula is 1/2 base times a times sine of theta. So in other words, if I go back up to this triangle, it's 1/2 times the two sides that are interlocked with the angle, the sine of theta. So basically, if you have side angle side, you can use this area formula right here. I would jot this down. So area equals 1/2 BA or AB times sine of theta. Okay, one quick example using this formula. Here it is again. So area equals 1/2 side A times side B times sine of the angle in between. Okay, so you want a garden to have an area of 100 square feet. And I should clarify, sorry, this is a triangular garden. One side is going to be 20 feet, and the adjacent angle to the side that is 30 degrees. Find the length of that other adjacent side to the given angle. Okay, so I know the area of the triangle, that's 150. I know one side is 20 feet. And I got to find the adjacent side to that, but I know that the angle in between is 30. Okay, so probably you want to visualize the triangle first. So I have 30 degrees, and that's in between the side of 20 and the other side that I don't know. Okay, and then I know the area of the triangle is 150. So I know A is 150, and I know side A is 20, and I'm going to solve for side B, and I know the angle in between is 30 degrees. So make sure your calculator's in degree mode. I'm going to multiply by 2. I'm going to divide by 20, so some easy math, kind of isolating that b times sine of 30. So 150 times 2 is 300, divided by 20 is 15. Then I can divide by sine of 30 degrees, and I got 30 feet. So this unknown length here, B, is really 30 feet. So there's just a quick application to a new area, a triangle area formula. And that is it. So enjoy the rest of your day.